Greetings, Earthlings, and welcome back to Earthlings 2.0, the show where we imagine how we could be better versions of ourselves and build a collective future we actually want to live in. On the show, we've talked a lot about decarbonizing aviation. We've explored it with planes powered by hydrogen or electric ones that can take off and land vertically. And we've even discussed the potential of sustainable aviation fuel. Links to all those shows are in the show notes. So check them out if you want to listen to them. Today's Tech Spotlight is with a company that says the fastest way to get carbon out of aviation isn't electric or hydrogen. They say it would be faster to start with hybrids first, similar to how hybrid cars were the precursor to electric cars. But before we get to the details, I'm your host, Lisa Ann Pinkerton. I'm the CEO of the award-winning PR firm Technica Communications and the founder of Women in Cleantech and Sustainability. Prior to this, I was an award-winning environmental science reporter for NPR and PBS. And thank you for joining us today as a listener, whether this is your first episode or your 50th. We really appreciate you being here. We hope you like what you hear, and we'd love to connect with you more. So you know how to do that: social media, send us an email. You can also join our Substack newsletter. And if you really want to tell us how you think the show should evolve, please take the listener survey and we will adhere to some of your recommendations. And if there's anything you want to do to really help the show thrive, the best thing you can do is to share this episode or the whole show with a friend of yours. Next time you're talking podcasts or talking about sustainable aviation, go ahead and mention Earthlings 2.0 if you think that they would enjoy it as a resource. And this is going to help us grow our community. Now let's dive into today's topic. Our guest is from Ampaire, the leader in developing hybrid electric propulsion for aircraft, designed specifically to reduce emissions, noise, and operational costs. Ampaire has already completed over 30,000 miles of successful test flights, and they've even proved that you can run their propulsion system on 100% SAFs produced from electricity and carbon dioxide. Joining us to talk about their achievements is Kevin Noertker. He's the CEO and co-founder of Ampaire. And prior to founding the company, he held various roles in engineering at Northrop Grumman and got his start as an undergraduate research fellow at NASA's Jet Propulsion Laboratory. Kevin, welcome to Earthlings 2.0.
Lisa Ann, it's wonderful to be here. Thanks.
So let's kick it off with explaining how your technology works. What is this hybrid technology that you've developed for aviation?
So at Ampaire, we're building hybrid electric technology, which takes this phenomenal electric vehicle tech from ground transportation, which we know and love, and integrates it into airplanes in hybrid electric form, much like a Toyota Prius, where you have part of the system coming from a combustion engine and another part of the system coming from an electric vehicle system. So in our planes, we have those two pieces coming together into what we call amp drives. Those are hybrid electric propulsion systems that we can place into planes that are in the current fleet, retrofitting or upgrading them, also enabling folks to design new planes around that.
Thank you for that. And so specifically, how does it work for takeoff, cruise, and landing?
So in our launch product, in this corner segment of the market where we're beginning, these types of planes are operated for regional aviation. And generally how they're flown is you need a lot of power during takeoff and climb and pretty modest power during cruise. And they fly between 50 and 500 miles for those flights. And so for that base load of power, that's where we're using the combustion engine. And the peak power for takeoff and climb, above that base load, that's where we get our boost from the electric systems. So think a combination of the two during takeoff and climb, and mostly a very fuel efficient combustion during cruise. Now, this gives you a lot of opportunity because you're able to both add power to the system using your electric. You can also pull power back and actually recharge your batteries in flight. For example, if you're landing at an airport that doesn't have any charging infrastructure. And this gives phenomenal flexibility in the operations while still delivering over 50% fuel savings, which is pretty phenomenal for the airlines and operators of these planes.
Yeah, that is pretty phenomenal. And when you're saving that level of fuel, you're also cutting those emissions?
That's correct. So this is a direct emissions reduction. So a lot of the listeners here might be familiar with some of the other strategies, partners of ours who are going after other means of reducing the life cycle emissions in aviation. So for example, sustainable aviation fuels that are made in a variety of ways. We also think that it's important to bring an equipment solution that actually drives the fuel consumption of these systems down. So sustainable aviation fuels are great. Burning half as much is even better, twice as good, in fact. And so we think that we're able to help out in some pretty meaningful ways by bringing these systems to market and enabling people to adopt the new technologies in a very safe way.
And why do you think that a hybrid approach is going to have a smoother path towards acceptance by regulators compared to electric or hydrogen offerings?
Sure. So there are a few reasons why hybrid electric will be the first to enter market commercially in broad scale. And I segment this really into four different factors. You've got technology, infrastructure, market applicability, and safety. So, from a technology standpoint, hybrid electric is not limited in the payload range or vehicle performance. Unlike, for example, batteries are held back in many cases by heavy, um, uh, by their weight, their energy density, which limits the range or payload of fully electric. Or hydrogen struggles sometimes with volume and the integration of that technology. From an infrastructure side, hybrid electric has no new infrastructure requirements. Again, the reason hybrids expanded rapidly on the ground into so many markets is you didn't have to worry about range anxiety or where you're going to plug in. And that's really important from a rolling out new infrastructure, not as a prerequisite, but alongside the growth of the markets. Now, for those markets and the market acceptance, we think hybrid electric enables upgrades of the existing fleet, which is much faster entry point into a broad market than going after unique aircraft designs. While the future is definitely new designed airplanes that are more fuel and aerodynamically efficient, the first steps are to upgrade the existing fleet. And I mean, I like to think the battle for sustainable aviation is happening above our heads right now, and we're losing it because all those planes are burning traditional fuels at 100% fuel consumption. So it's important from a market applicability standpoint that you can upgrade those existing planes, and hybrid electric is one of the few technologies that drops straight into those operations. And then finally, from safety, aviation is a very risk averse industry, and new technologies have to earn their trust. It's not a theoretical thing, it's about earning trust. And there's really no way to bridge trust that's better than to have a baseline safety case of the already trusted technology, which is combustion today, but to incorporate thoughtfully the electrification technologies in hybrid electric, build familiarity both with the end users and the general public as well as with the regulatory bodies, and to in that way slowly incorporate novel tech and eventually transition fully into that new technology instead of in one leap in a course of a few steps. So, technology, infrastructure, market applicability, and safety all are directly lined up in hybrid electric. And each of these other alternatives struggle in ways in one of those categories or another.
Well, because these other solutions are entirely novel, whereas what you're doing, there's some proven technologies that is being utilized. So I can see how it would be a simpler path to regulatory approval.
That's right. I mean, just think if something happened in the electric vehicle system in flight. In our system, you switch over to the combustion engine and you fly home safely. Now we think the electric systems are actually going to be safer and more reliable and lower cost than the original combustion. But again, I don't have to prove that up front. I can prove it over time. And that ability to fall back onto traditional and trusted tech is a massive accelerant for market adoption.
And you mentioned the hybrids on the road being accepted or coming to market sooner, and we saw them all over. I remember reading a report out of San Francisco about the adoption of hybrid vehicles. I don't know if you're familiar with this, but I'm going to out a limb and talk about it. What I found was so interesting was that when respondents of these owners of these vehicles, and they knew they had these vehicles because they had the little sticker that allowed them to go into the HOV lane. So the reason the vast majority of people had bought a hybrid car was so that they could drive in the HOV lane. Wa- Wasn't actually because it was cleaner.
That is interesting. You
And
know,
yeah.
sometimes there are these secondary effects that drive adoption in addition to the primary outcome.
Yeah, and I wonder if the aviation industry could take a nod from that over time. And of course, you wouldn't want your plane to get bumped to the back of the runway, for a hybrid aircraft. But then you might opt to, select flights that are on a hybrid or electric or hydrogen aircraft because you're going to get priority takeoff or something like that, right? As a way of helping to encourage this adoption.
Absolutely. That's a really creative idea. And there are some similarities on when you're looking at the way policymakers can support industry's growth, that even second to subsidies or any of these other discussions people normally have, sometimes there are other factors. So, landing slots or gate access preferences that are sometimes quite competition at some of these airports. There are ways to offer a delightful experience uh, because somebody adopted the better for the worth technology.
These little nudges that appeal to our our baser instincts, I
Hmm.
guess.
Hmm.
But I digress. So I wanted to ask you, related to your technology, I've read that some of the hydrogen planes run a little slower, or no, maybe it's the electric planes I was thinking about run a little slower,
Hmm.
and I'm wondering, is speed affected through your powertrain system, your hybrid system?
So our aircraft have the capability of flying the same speed as the original planes. The question for our customers and what they're generally asking us is, what is the fuel optimal speed to be flying at, or given a kind of a time value uh, assessment on the economics, where being in flight for a longer period of time has its own costs. What is the optimal speed at which we should fly? So many of our customers will choose to fly the same cruise speed as they originally did. Some will choose to fly a few miles per hour, a few knots slower, in order to hit the most fuel efficient point.
And what did you learn when you ran your propulsion system on 100% SAF fuel?
So the key learning there when we were running our system on SAF is that it worked just about normal and exactly as we expected it would. It's the delight of great engineering is when everything does exactly what you think it should, and that's what we saw with that sustainable aviation fuel demo. And this is really important for the industry, interoperability of these solutions where you don't have to pick one or the other. In fact, you should pick a combination of both. This is where you get some really amazing enabling factors. So, for example, in sustainable aviation fuels, you may be aware that they're running into some challenges around the cost per gallon being at a bit of a premium, or with the volume of production being at what is it, 0.1% of the demand in the industry. And so if you're able to burn half as much SAF, now all of a sudden your economics, the cost goes down by a factor of two. If you're able to burn half as much SAF, the production requirement to get the same net benefit to the climate goes down by a factor of two. So these are ways that we're able to work really well together. And I believe the world can understand theory, but feels through demonstration and witnessed actions. And I like us taking actions to show the future, not just talking or theorizing about it.
Yeah, I like that too. Get out there and do something, you know? You can only talk about it or, ideate on something for so long, but this reality really encourages action, being in action.
Absolutely.
One other question I had for you related to the technology, and then we'll get into some of the other aspects of what you're doing. I remember back in the day when hybrid cars were really gaining market share, and then you had electric vehicle manufacturers attempting to also get into the market. There was an argument being made that with hybrids, you basically have to maintain two engine systems. And so your maintenance is more involved. Everything is double, right? And so that was an argument for why just go for electric. What would be your take related to applying hybrid for aviation?
We hear the same types of arguments or debates or questions, and it's a valid question. Is if you're adding complexity, then would you expect costs to go up? One of the beauties of how our system is architected is that we've been able to do so in a way that maintains. We actually believe will reduce the cost per hour to maintain these systems. So even though we've added the electrification components, the relative complexity of those is pretty light. We're able to really drive a positive maintenance and life cycle economics on the system itself, and then dramatic reduction in costs from the fuel savings at an upfront price, which is equivalent to or can slightly undercut the price of the combustion engines that are already out in market. So if you have capex neutral upfront and operating cost benefits thereafter, this is a really economic driver for adoption, and maybe much like those carpool lane stickers, the economics in this case is likely going to drive the sustainable decision because it makes good business sense. It's not just good for the environment, but it is the right decision for a business to switch over. And the maintenance is a real important aspect of that as well.
Yeah, I think you're right, and we can cross our fingers that some of those savings might get passed down to the ticket holders flying these airplanes. Maybe we'll get baggage included again someday in our
We
flights.
can only dream, huh? It's dreamers here. One of the
That's
really
right.
amazing one of the really amazing things though about that is that in addition to like so maybe the economics get passed on to the passengers or we get the our bags back, but one of the even if that doesn't happen, a beautiful aspect of aviation is that when the per seat economics improve, there's this elasticity in the market where airlines are able to provide more frequencies or more frequent service to more places. And what we will see, even if ticket prices do end up staying the same, we're going to see more convenience factor for passengers. So think about your smaller local airport that, we're right here at the Long Beach airport, doesn't have a whole lot of service, just one or two major
Mhm.
airlines flying in. But it might make a lot more sense for more point to point connections or hub and spoke connections if those flights were more economical. And this is exactly what we plan on seeing is that as the economics get better, the flexibility and convenience of those flights is going to go up. And that's going to benefit all of us again, just like those carpool lane stickers.
I find that interesting that you say that because when you think about the regional um, air travel, typically we're looking at places that aren't, they're not large enough to have larger flights, right? So they might have higher costs, or the cost of living in those regions might be higher just generally. I'm thinking of remote locations, either island nations or up in Alaska. There's some towns where you can only get in and out through. airplanes, and this technology making enabling transportation to be more economical and therefore have more frequency of travel. Does that make sense?
That's absolutely right. Not only does it make sense, but it actually perfectly mirrors the operations where we've deployed our planes. So back in 2020, when we were flying those essential air service routes with Mokulele Airlines on the island of Maui, doing the daily operations as their operations would in this pilot project, and showing, not just talking, but showing the benefits in that route. Or when last year we flew all the way up from California through Canada up to Fairbanks, Alaska, and gave a firsthand view to many of those communities that aviation is a lifeline service, right? This is not about some uh, premium high net worth individual type service. This is how people get their eggs and milk, and how they get their doctors, right? This is really essential, and that's so important when we think about the positive impacts on aviation, which, those of us who are living in big cities in the United States might think of aviation differently, but a whole lot of the world sees aviation as that lifeline service, which is absolutely critical, and reducing the cost increases the positive social impact and the economic impact that this connectivity can bring.
Yeah, and I think, a second and third order of effect might be that these locations are less isolated or more people
That's right.
are able to experience them, which I find
Exactly.
really fascinating. When you're thinking about, technology is not just for technology's sake, but it has all of these um, additional impacts that some people don't even recognize or can predict would happen. But once, Earthlings get a hold of some technology, they can be pretty inventive with it.
It is amazing what happens when you connect people, isn't it?
hmm So let's talk about. You mentioned some of the flights that you're doing. How many customers do you have? What's the scale look like for you? Are you approved to be running commercial flights right now, or do you have preliminary approval? Give us a lay of the land.
Sure. So we have flown about 30,000 miles so far. We have a fleet of three aircraft that are hybrid electric today, running varying types of demonstrations and experimental flight tests. And so we've gotten over a dozen different airworthiness approvals from the FAA and their equivalents elsewhere in the world to run these early exploratory operations. We have one big milestone with the regulators still in front of us, which is to get that approval for commercial operations, where somebody could actually go and buy a ticket to fly on an airline that's operating one of our systems. And we think that we're, call it 18 months or so away from that. Of course, conditional on our next capital raise coming in on time, but very excited about that, because when we look over this next 2 year period, this is the transition from um, and really the first introduction of sustainable aviation, electrified propulsion into the world, and this is the first impression that people will have. And when you think about first impressions, it's really important to make a good one. And we want to make sure to leave a good legacy for the industry so that people, when they think about electrified aviation, they don't think about limited range or apologetic performance. And instead, they're thinking about a phenomenal experience, a good economics. And so that's where we're working toward commercialization over these coming 2 or so years, and the customers that are quite excited about this. So we have orders for we've got orders for dozens of these firm orders, and then a backlog of hundreds of additional softer orders, looking at buying these systems and putting them in place. These are from operators that some that you've heard of, others that you haven't, which are flying either passengers or cargo. Sometimes there are also dual use applications or government applications where the added capabilities of these systems is really compelling. And so all of that is what we're going to realize over these coming 2 years.
Okay, that's cool. I really like that future look that you've got there. And it has me thinking too around, so you were mentioning within 18 months, assuming everything goes as planned, you should have your commercial, you should be cleared for commercial flight. And so I'm looking in the next sort of, if we expand that view out, so the next 10 to 20 years, how do you think what you're doing today with the hybrid electric is going to influence the rest of sustainable aviation over the next couple of decades?
Hybrid electric is the gateway technology to the future of sustainable aviation because it marries so well with sustainable aviation fuels. As those come into production, we're able to enable to expand the impact of SAFs by reducing the consumption of them. For those communities where sustainable aviation fuels aren't available, where the economics of a SAF maybe just don't make sense, we'll be able to reduce the cost of that flying in a way that is going to increase that level of connectivity. And what we really see when you're talking about that 10 to 20 years out, by that point in time, we're going to be seeing larger planes looking up towards transport class vehicles that are going to become more electric over time. So reducing the reliance on carbon fuels for some of the energy needs, and then weaning ourselves off of that using the electric vehicle systems. Similarly, we're going to see more and more electric planes, ultimately fully electric planes, in many of these market segments. So I think while some people are talking about fully electric, for example, vertical takeoff and landing, the expanded market that's enabled with hybrid variants of those planes could be really impactful. And then ultimately leading toward the fully electric visions that we all have for this industry. It's pretty exciting, and this is the way to get there thoughtfully. It's the way to actually get there quickly, and it's a way that we can get there together. And so those are the things that I'm most excited about in this 10 to 20 year transition. And just zooming out, aviation goes through massive transitions once or maybe twice in a century. A little over 100 years ago, you had the dawn of powered flight. Halfway between then and here, you had the jet age. These are the two things that you think about with aviation. Each of those was when new propulsion came into this industry and changed everything. It's happening again right now with this technology, a change as big as the jet age. And this is our opportunity to see it through in a positive way. And so that's what makes these next few decades so phenomenally exciting, is this is the new jet age, and it's going to change everything looking forward. And it's certainly a great reason to be getting up every morning.
Well, thank you, Kevin. I agree with you. I feel like we're reaching like a new golden age of aviation, and people are going to look back on this time and be, I think, hopefully, very impressed with the advancements that were made towards a cleaner aviation future. So, thank you for being on the show with us today.
Absolute pleasure. Thank you.
And Earthlings, thank you for joining us as well. We will see you again on another turn of this beautiful blue green space flower that we call home.